In part B of the experiment, we examine the phenomenon of dialysis. We begin by combining 15 milliliters each of the three aqueous solutions: 10% sodium chloride solution, which is the source of the chloride ion, 10% glucose, and 1% starch. The combined solution is poured into a bag made out of dialysis tubing. We then immerse the bag in deionized water. We check the water after an amount of time has passed to see which solutes have managed to escape through the dialysis tubing. We also check the solution in the dialysis bag at the end of the experiment to see which solutes remain. A reasonable question at this point would be to wonder when we should test the water outside of the dialysis bag. Now, the procedure for the experiment tells us that we should test immediately after the dialysis bag has been immersed in the water, and then after 30 minutes have passed. This procedure, as given, is easy for us to follow. However, testing the water after the dialysis bag has been placed in it totally defeats the point of trying to test the water at the true beginning of the experiment. We would like to show that the water initially had no solutes in it. Once the water has been in contact with the dialysis bag for any length of time, even as short as 1 second, enough time has passed that some of the solutes may have escaped the dialysis bag. There's really no way that we can obtain a sample without at least 10 seconds having passed, and that cannot be accurately considered to be a 0 seconds or even 0 minutes result. If we are truly to test the contents of the water at the instant the experiment begins, it makes far greater sense to test the water before it even touches the dialysis bag. Whether we test the water 1 second or 5 seconds or even 500 seconds before it comes into contact with the dialysis bag is totally irrelevant. The point is that the composition of the water should give the same test results at any of those times up until the bag is actually added. For that reason, I have changed the procedure so that the sample tested at 0 minutes was taken before the dialysis bag ever came into contact with it. I then test the water after 30 minutes exactly as the procedure tells us we should. Finally, I test the leftover solution in the dialysis bag to see which solids, if any, remain. You will notice that the table under Part B of the report sheet has 2 different types of rows in it. Some of the rows say observations. For these rows, write down exactly what you see. For example, you might see a clear colorless solution, or you might see a cloudy white solution. The remaining rows ask you if a particular solute is present. If it is, put a plus sign in the box to indicate a positive test. If the solute is not present, indicate this with a minus sign for a negative test. Finally, answer the questions under this part. Commencing Part B, here are the 3 solutions which will go into the dialysis bag. 10 milliliters of each solution are combined. Most of this solution is then poured into the dialysis bag. The dialysis bag is then immersed in deionized water. And here we begin the time equals 0 minutes test. We start by adding the silver nitrate to a sample. So here's our chloride ion test. We next add the iodine solution to a test tube to test for starch. And here is the result of the starch test. And finally, we test for glucose using Benedict's reagent. Benedict's solution is added to the test tube, and the test tube will be heated for 5 minutes. After 5 minutes, we return and noticed little, if any, change in the appearance of the test tube. And here we see all 3 test tubes: the chloride test, the glucose test, and the starch test. After 30 minutes, I'm going to remove the dialysis bag from the deionized water in which it had been sitting. And then I'm going to pour a sample of that water into a graduated cylinder for later testing. The contents of the dialysis bag are poured into a different graduated cylinder, also for testing. Here, I'm going to test the water that was outside of the dialysis bag after 30 minutes. Again, this is the water outside the bag, not the contents of the dialysis bag. So there, I've added the silver solution to test for chloride ion. Next, I'm going to add the iodine solution to test for starch. And finally, I'm going to add Benedict's solution to test for glucose. I take the combined solutions and add them to a hot water bath for 5 minutes. After sitting for 5 minutes in the hot water bath, we clearly notice a transformation. Now, this doesn't look like we might have expected for a positive test. However, for the solution to have changed in any way must suggest that some of the glucose must have escaped the bag. So, although this is a somewhat anomalous test, I would still consider it positive. I'm now going to show you pictures for the results of the tests on the contents of the dialysis bag. Here is the result of the chloride ion test performed on the contents of the dialysis bag. And here is the result of the test for starch. And finally, the result for the test for glucose.